Okay, chapter 2.6, solving two-step equations. Now the important point here is two-step. So we will have adding and subtracting, which is one step. Add or subtract. And the second step would be to multiply or divide. And it's kind of like a puzzle. You have to pull the equation apart in the right order so that you can solve for that variable. We're trying to find out what x is or y is or something like that. And the first example is negative 3x plus 5 equals 2. And you can see that there is a multiplication of 5 times, sorry, 3 times x is multiplication, and then there's an addition problem, it's adding 5. And we're working our way to get down to the x all by itself on one side. We want x to equal something. So x has to be by itself. We can't divide yet, because if we divide 3, we have to divide everything by 3. So it would be 3 divided by 3, 5 divided by 3, and 2 divided by 3. And we could do that, but that's complicated. We want to start with subtracting, the opposite of adding. So we're going to subtract 5 from both sides, and then we're going to rewrite our equation. 5 minus 5 is 0, so we just leave that alone, and 2 minus 5 is a negative 3. Now this looks manageable already. We're already back to something that we like. We want to get x by itself, so negative 3 times x, we're going to divide by negative 3 to undo that multiplication problem. And then we're going to do the same thing to the other side. Negative 3 divided by negative 3, and we get something pretty easy to look at. We get this cancels out and it leaves x, and negative 3 over negative 3 is 1 over 1, so it's just actually positive 1. X equals 1. X equals 1. And if we put that back in, instead of the x we put in a 1. Negative 3 times 1 is negative 3. Negative 3 plus 5 is equal to 2. We can see that work. Second example is more of a fraction or a division problem. So we have x over 8. X over 8, it looks like a fraction, and it is, but it's also a division. It's x divided by 8. X over 8 minus 1/2 equals negative 7/2. That 7 does not look very nice. Let's see if we can do a better job. Negative 7/2. Okay. Now, it's lucky that we have halves here, because if they're both halves, we can add and come up with something that works. Again, we're working our way down to the x, and we're going to work starting somewhere else and then work toward the x. That's kind of how I think about it. I'm not sure if that makes sense with you, but we could multiply by 8 right here all the way across, and that would actually work just fine. But we usually will start not with the x, we'll start somewhere else and then move towards the x. So we're going to add 1/2 to both sides, because we want to get rid of this minus 1/2, because negative 1/2 plus 1/2 is 0. So we get x over 8 still, and it's equal to, because these cancel out and become 0, negative 7 plus 1/2. Negative 7/2 plus 1/2 is negative 6/2. And then I'm going to look back at it and say, well, I have to get my x by itself. So I'm going to multiply by a reciprocal. That would be one way to look at it. The opposite of 1/8 is 8 ones. This is x over 8, but we just know that we need the x's, or the 8's, to cancel. So we multiply by 8 to cancel that 8 out over there, but we put it in fraction form so that we can see that we've got an 8 on the numerator and an 8 in the denominator, so that we know we can simplify before we multiply, leaving the x by itself, because 8 over 8 is 1. Now this is 6. It's starting to look like another number, but it was definitely a 6. And again, I can multiply or I can simplify first. I like to simplify first. 8 over 2 is the same thing as 4 over 1. And then when I multiply negative 6 times 4, I get a negative 24, and 1 times 1 is 1. So I can write it like this, or I can just leave it like that. 8 is a negative 24. And if I go back up here and I put negative 24 in for x, okay, negative 24 over 8 is 3. And if I take 1/2 away from 3, I get 2.5, and negative 2.5. Ooh, negative 3.5. Boy, I was confused there with my negative numbers. We all need to practice those. Negative 3, negative 24/8, let me rewrite it just so we can see it, is negative 3 minus 1/2 equals negative 7/2. Negative 3 minus 1/2 would be negative 3.5, because you're going farther down. And is that equal to negative 7/2? Well, if I put it in an improper fraction, 2 times 3 is 6 plus 1 is 7/2. And it works. Okay, that was actually a little harder to show. Now there's one other thing that we have to understand. It's called combining like terms. And we always want to think about doing that before we start manipulating the problem. And actually, it is part of the puzzle. We just have to kind of take those apart. So for instance, if I have 3 plus 4x plus 7 plus x, I can combine the 3 and the 7 to make 10. And I can combine the 4x and the x to make positive 5x. And one thing I have to remember is that this positive sign goes with the 4x, and this positive sign goes with the x. And this positive sign goes with the 7. So for instance, if we do a negative, we might start with that 3 again and go minus 4x minus 7 minus x. And it doesn't matter. Any combination of pluses or minuses, they change something. This 3 and the negative 7 go together. So 3 and negative 7 is negative 4. So I combine those things, combine my like terms. These are like because they don't have an x. These are like because they do have an x. And if I had a y somewhere, I'd put those together. And then I take my negative 4x and my negative x, and I combine those. Negative 4x and negative x is negative 5x. Because they're both negative. And so that's what that would look like. So sometimes we have to do that on problems. We'll have, this is a simple one, 3y minus 8y is 25. So I combine those. 3 minus 8 is negative 5y equals 25. And then I undo everything, divide both sides by a negative 5 because I want the y left alone. So that leaves me with just y. And 25 divided by 5 is a negative 5, because negative 5 times negative 5 is positive 25. Now that's a simple one. They get a lot more complicated. Let's see if I can find you one that's a little bit more complicated. I think your next lesson is where they start to get more complicated. So we'll just leave that to you, and I suppose we've gotten close to our 10 minutes, so we'll stop here.